In the previous video, we configured port security on gigabit 00 by making the port an access port and then enabling port security. MAC addresses were dynamically learnt. So this MAC address was dynamically learnt on port gigabit 00, and hence show port security shows us that the address permitted on that port is this MAC address. It was dynamically learnt and has been added to the database of permitted MAC addresses on the port. Only one MAC address is allowed on gigabit 00. So max secure MAC addresses is 1. If a violation does take place, the security action is to shut the port down. Now let's configure MAC addresses statically. So let's configure port security on gigabit 01, but do it manually. So I'm going to use the commands switch port security, specify a maximum. The default is 1, so I'll say 1 here, and what you'll notice is the output is not shown because that is a default command on this interface. But what we'll do now is type switch port security MAC address, and what I'll do is explicitly specify the MAC address that's allowed, and just to prove the point, I'll specify a different MAC address of, let's say, 3. Now at the moment, the MAC address on this router acting as our PC is this. So it's a different MAC address. The PC can still ping router 1 because we haven't explicitly enabled port security yet. So we've configured what the MAC address is. We've configured the maximum MAC addresses allowed. I'll specify the action to take if there's a violation. Notice we have protect, restrict, and shutdown. The default, as we've seen, is shutdown. Now protect drops packets with unknown source MAC addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value. In other words, we are dropping packets from unknown source MAC addresses, but there's no logging. At the moment, we're only allowing one MAC address, but as an example, if you had specified a maximum MAC address of 3 and a fourth device tried to send traffic, that device's traffic would be dropped. Restrict drops packets with unknown source MAC addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value. So that's very much the same as protect, but in addition, it causes the security violation counter to increment. In other words, there's going to be the generation of log messages and counters will increment. Shutdown is the default, which we've already seen, and that puts the port into error disable mode and sends an SNMP trap notification if SNMP is configured. So I'll continue to use shutdown so that we can see the output. Our configuration looks as follows. Remember, the MAC address of this device is a different MAC address. It's this, but we are only permitting this MAC address. But because we haven't globally enabled port security is not active. So we can use the command do show port security. At the moment, port security is enabled on gigabit 00, but not on gigabit 01. We can also use the command do show interface status. At the moment, both gigabit 00 and 01 are connected. So port hasn't been shut down because of port security. But now when we type switch port security, we're actually enabling port security. And once again, we need to have this configured as an access port. It can't use DTP. So do show run interface gigabit 01. And while I was doing that, notice we received a port security violation message. We were told that there was an issue with this MAC address ending in 2 on gigabit 01. We have only permitted the MAC address ending in 3. Maximum MAC addresses that would be permitted are 1. Only one MAC address is permitted. In this case, when we look at the command do show interface status, we can see that the port was error disabled. So show interface status is a command that shows us the status of the ports. We can see this is connected, but this port is error disabled. So show port security once again shows us once again that gigabit 00 and 01 have a security action of shutdown, but the only port that's currently shut down is port 01. So show interface status shows us that this port is still connected, this port is error disabled, and now this host can't ping router 1 because the port is error disabled. Show port security interface gigabit 01. We can see that port security is enabled on this port. It's currently shut down because of the mode being shut down. This is the last MAC address that violated the security policy on that interface. So on router 2, if we change the MAC address to the MAC address expected by the switch, it still won't be able to ping because of the violation that took place. So we need to go into the port and shut it down and then no shut it. And once that's done and the switch learns the correct MAC address, the device should be able to ping. So at the moment the MAC address hasn't been learnt. Just waiting for the interface to come up. So show interface status. Let's see what's going on. Interface is connected. And now the ping succeeds. I was just too impatient and I needed to wait for spanning tree and other protocols to sort themselves out. But show port security interface gigabit 01. We can see port security is enabled. Violation mode is shut down. At the moment, the port status is secure and the interface is up. Last MAC address that was seen was this on that port. No security violations occurred. Maximum MAC addresses once again allowed is 1. Total MAC addresses seen is 1. One MAC address has been configured because we manually configured the MAC address on the switch. So if I save this configuration and the switch reboots, this MAC address is stored in the saved configuration. So that's different to what we have on gigabit 00. Here, when the switch reboots, it would simply learn the source MAC address from a frame received. So the first device that connects will have its MAC address added to the database. So show port security address as an example shows us the two addresses. This one was statically configured. This one was dynamically learnt. So the MAC address on this interface was configured. This was dynamically learnt. Now the example on the right is where you explicitly allowing a specific MAC address onto the network. The example on the left is where you are restricting the number of MAC addresses permitted on a port. So on the left, you would stop a user connecting a hub, as an example, to the network and connecting multiple devices to the port. Whereas the example on the right is where we are limiting traffic to a specific MAC address. The problem with this method is we are having to work out what the MAC addresses of the devices are and then manually configuring those MAC addresses. So let's look at another way of doing it.